Now we will do this problem on projectile motion. This is the problem. An object is thrown from a height of 120 meters with a velocity of 20 meters per second at an angle of 30 degrees above the horizontal. Calculate, there are three things to be found out. Calculate the time of flight. Okay, I will change the calculate the time of flight, horizontal distance moved by the object during its journey, velocity when it strikes the ground. So three things we have to find out. This is the diagram for that. See, there is a projectile here and which is projected from this point and it moves along this direction. Okay, so this is 120 meter, 20 meter per second, 30 degree. So 120 meter is the height. See here, it's given 120 meter. Velocity of projection 20 meter per second. So it's given here 20 meter per second, or it is written here 20 meter per second. At an angle of 30 degree above the horizontal. So you can see that this is 30 degree above the horizontal, and this is called, of course, trajectory. The path taken by the projectile is called the trajectory. Okay, now let us do this problem. There are three subdivisions altogether. We will do them one by one. Okay. So what has been done here? This velocity of projection has been resolved into two components, 20 cos 30, because this is 30 degree. This is 20 cos 30 degree. This is 20 sin 30 degree. So horizontal component 20 cos 30 degrees, horizontal component of velocity. Vertical component 20 sin 30 degrees. It is better to consider sign convention whenever the motion involves two directions, one opposite to the other. See here, the projectile first goes up, then it comes down. So you give a sign convention. So the sign convention can be anything. So here, upward negative, all distances, velocities, acceleration, if it is upward, it is negative. If it is downward, we can take it to be positive. Okay, this is sign convention. If you want it to take it the other way around also, fine, there is no problem. Okay, so the whole thing given in the problem is simply shown here in the diagram. So we will now go to the first subdivision, see how to do this. Here we are going to use S is equal to ut plus half at square with sign convention, right? So this is S, which is positive because your projectile starts from here, and of course the real path is this one, but considering vertical component, initially here, finally here, that is it strikes the ground here. So how much it has moved down vertically? That is 120 meter. It is downward. Only vertical component I am saying, only the vertical component which is downward, so it's written positive. So S is equal to ut. U means initial vertical velocity. 20 sin 30, you see that this is in the upward direction. So I have to put minus 20 sin 30 here. This is ut. S is equal to U into T. Why negative symbol here? Because the velocity of projection is component of the velocity of projection in the vertical direction is vertically upward. According to our sign convention, it is negative. So we are putting negative here, negative symbol here. Okay, then plus half at square, but a is equal to g is 10, so half into 10 into t square, which is 5t square. But this is positive. Acceleration due to gravity, which is acting downward, so g is 10 meter per second squared, but that is positive because it is downward. So half into g into t squared, half into 10 into t squared, so 5t square. This is one equation. From this you can solve for t. right? Look at this. 120 is equal to, this 120 is equal to minus 10t, because sine 30 is half. You should be knowing very well. Sine 30 degree, better to mention here sine 30 degree, which is half. So minus 20 into half minus 10. Okay, this t will come as it is, and 5t square, of course. So this is on simplification. 5t square minus 10t, this 120 will come to this side, it will become minus 120. So this is a quadratic equation. You can simplify this by dividing it by 5. Okay, so dividing the whole equation by 5, t square minus 2t minus 24. 120 by 5 is 24. You can easily see that this can be factorized. Right? T, when you factorize this, you get t minus 6 into t plus 4 is equal to 0. That means t minus 6 is equal to 0, or t plus 4 is equal to 0. But t plus 4 is equal to 0 will give you t is equal to minus 4 seconds, but that we have to neglect, because practically it is not possible to have t is equal to minus 4 seconds here. Okay, t equal to 6 seconds is one answer for this t. T is equal to minus 4 seconds is another answer, because it being quadratic you will have two roots, t equal to 6 and t equal to minus 4, but t equal to minus 4 can be neglected, right? So we have t is equal to 6 seconds, right? T is equal to 6 seconds. Is it all right? Go to the next one. R means the horizontal distance moved by the projectile during its time of flight. So horizontal velocity into time of flight. Time of flight is 6. Horizontal velocity 20 cos 30, which will not be changing because gravity acts vertically. Therefore, the horizontal component of velocity will not be affected by gravitational force. Now cos 30 is root 3 by 2. 20 into root 3 by 2 will be 10 root 3 into 6. So you simplify this. Right? Here you have 20. Here you have 6. So 120. Cos 30 root 3 by 2. This 2 and 120 you can cancel by 2. And 120 cancel by 2, so 60 root 3, which on simplification will give you 104 meter as the answer. So for the second one, horizontal distance moved by the object during its journey is 104 meter. I'll just change it. (104 meter). That is this 104 meter. Then next one. The next one is velocity when it strikes the ground. See, when it strikes the ground, when the projectile, when it strikes the ground, it is that it has got a velocity which is in the direction tangent to this parabolic path. Here you should draw, that is at the striking point you should consider tangent to this parabola. That will be net velocity, which you can resolve into two components, horizontal and vertical. Horizontal component will be same as this. Okay, so this is the actual velocity. This is tangent to this parabola at this point. You can resolve this into two components. Okay, Vx and Vy. Net velocity you have to find out. Okay, you will have to complete the parallelogram. The parallelogram is a rectangle here. So I'll just draw another diagram here close by so that you can see it better. Okay, so this Vx I have drawn, this Vy I have drawn. Vy is vertical component of velocity at this point. You can consider this point say as B or something, At B, vertical component of velocity Vy. At A, let's call this as A. At A, vertical component of velocity 20 sin 30 numerically. So Vy, if you want to find, you can use V equal to U plus At formula. But of course this Vx will be same as Ux because horizontal component of velocity will not change. Tan alpha is Vy by Vx. This is alpha, opposite by adjacent. Opposite is this Vy, adjacent is this Vx. Okay, proceeding towards the calculation. Vx is equal to Ux. Why? Horizontal component of velocity will not change. So this will be 10 root 3 on simplification. Okay, 10 root 3. What is the SI unit? Meter per second. Okay, this is this one. This Vx is 10 root 3 meter per second. Vy, you will have to use equation of motion. V equal to U plus At. This is U. U means velocity at A, negative symbol according to the sign convention. G is 10 into time. U plus At, A equal to G. G is downward, so positive. Time is 6 seconds. We already found out here. So simplify this. Sin 30 is half. Minus 20 into half, minus 10. G is 10. 10 into 6, 60. So this will be 50 plus 50. So Vy, this one, is 50 meter per second. So Vx, Vy. Vx how much? 10 root 3. Vy how much? 50. All in meter per second because they are velocities. Now net velocity will be root of Vx square plus Vy square according to law of parallelogram of vectors. This parallelogram being a rectangle here. So V is equal to net velocity. Okay. Okay, 10 root 3 for Vx. This one no Vx, 10 root 3. Vy, 50. So 10 root 3 the whole square plus 50 square. 10 root 3 the whole square will be 100 into 3. This is 300. 50 square will be 2500. So square root of 2800. Okay, that can be further simplified. The square root of 2800, no, that you can write as 2800, you can write as 400 into 7. That 400 square root will be 20, which you can bring out. So 20 root 7. I repeat, 2800, 400 into 7, 400 you bring outside the square root, that will be 20, then root 7. This is the net velocity. Then we have to find the angle alpha. So tan alpha is 5 by root 3 tan alpha. So you can find alpha. So referring to tables, you can find out the alpha to be 71 degrees. So velocity with which it strikes the ground has two parts, magnitude as well as direction. Magnitude we got as 20 root 7. At an angle of 71 degree with horizontal. Understood? Okay, thank you.